This is Spacetime, Series 22, Episode 68. Coming up on Spacetime, the monster black hole firing an energy beam towards Earth, discovery of 8 more repeating fast radio bursts, and astronomers uncover a treasure trove of ancient galaxies in the distant universe. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
New observations of the supermassive black hole at the centre of our galaxy suggest that it's shooting a powerful energy beam almost directly towards the Earth. The findings, reported in the Astrophysical Journal, are based on a new technique which has added ALMA, the Atacama Large Millimeter Submillimeter Array Telescope in northern Chile, to an existing array of radio telescopes spread around the world, which is studying our galaxy's central supermassive black hole. Adding ALMA to the network has allowed astronomers to determine that a powerful emission beam is being generated from a smaller region of the black hole than previously thought, suggesting it's pointed directly towards us. Most, if not all, galaxies are thought to contain a supermassive black hole at their centres, millions to billions of times the mass of our Sun. The one at the heart of our galaxy, the Milky Way, is located some 26,000 light-years away. It's called Sagittarius A star and contains about 4.3 million solar masses. But until now, a foggy cloud of hot gas and dust has shrouded the black hole, preventing astronomers from making sharp images of Sagittarius A star, leaving doubt about its true nature. Adding ALMA to the global network of radio telescopes studying this central monster has allowed scientists to peer through the fog. They used a technique called Very Long Baseline Interferometry, which electronically connects numerous radio telescopes around the world, allowing astronomers to create a virtual telescope as big as the Earth. By observing at a frequency of 86 GHz, the authors succeeded in mapping out the exact properties of the light scattering which is blocking their view of Sagittarius A star. The removal of most of the scattering effects has produced the first image of the surroundings of our supermassive black hole. In fact, the high quality of the unscattered image has allowed astronomers to constrain theoretical models for the gas surrounding Sagittarius A star. The bulk of the radio emission appears to be coming from a mere 300 millionth of a degree, and the source appears to have a symmetrical morphology. Now, this may indicate that the radio emission is actually being produced by a disk of infalling gas rather than by a radio jet. However, that would make Sagittarius A star an exception compared to other radio-emitting black holes. The alternative is that the radio jet is pointing almost directly at us. And that's a view supported by observations using the Very Large Telescope, configured as its own interferometer of optical telescopes. Supermassive black holes may generate the most energetic phenomena in the known universe. It's believed that around these black holes, matter falls into a rotating disk, an accretion disk, where stars, planets, and massive clouds are torn apart, ripped to pieces, and crushed. Most of this matter then passes beyond a point of no return, known as the event horizon, beyond which it falls forever into the singularity of the black hole. But not all the material is destined to be doomed to such a fate. Some of it's channeled along magnetic field lines before it reaches the event horizon. It's then focused into beams perpendicular to the accretion disk and shot out across the universe, forming quasars, powerful beams of energy visible across the cosmos. Of course, the strength of these beams depends on how much the black hole's feeding. The Milky Way's supermassive black hole, Sagittarius A star, is relatively quiet, so it's only nibbling on bits of gas and dust that get too close. Whether the radio emissions we're seeing from Sagittarius A star is being generated by the infalling material or the outflowing jet is still a matter of intense debate. Sagittarius A star is located in the southern sky, and so the participation of ALMA is important, not only because of its sensitivity, but also because of its location in the southern hemisphere. As well as ALMA, 12 other radio telescopes located across North America and Europe also participated in the network. The resolution achieved through this process was twice as good as any previous observations achieved at this frequency, and it's produced the first image of Sagittarius A star that's completely free of interstellar scattering, an effect caused by the density of irregularities in the ionized material along the line of sight between Sagittarius A star and the Earth. I'm Stuart Gary. You're listening to Spacetime. astronomers may be a step closer to finally solving the mystery of fast radio bursts following the discovery of 8 rare repeating bursts. Fast radio bursts are sudden, high-energy flashes at specific wavelengths, lasting just nanoseconds and originating at cosmic distances. But in that short time, they can release more energy than 500 million suns. The first fast radio bursts, or FRBs, were discovered back in 2007 in data from the Parkes Radio Telescope in country New South Wales. Since then, dozens more have been detected. Most are singular events, occurring just once at a specific location and then never heard from again. That's suggesting that they're caused by some sort of cataclysmic event, such as a supernova explosion. But astronomers are now detecting fast radio bursts that have repeated from the same location. That suggests a very different cause. Feeding black holes, glitching neutron stars, and highly magnetized neutron stars called magnetars are all suspected. Or it could simply be that all fast radio bursts are repeaters, with some simply a lot more active than others. Until the start of this year, only one of these mysterious signals, FRB 121102, was known to flash repeatedly. But then in January, a second repeating fast radio burst, FRB 180814, was discovered. Now, a new study on the pre-press physics website archive.org and submitted to the Astrophysical Journal has reported the discovery of 8 new repeating fast radio bursts by astronomers with CHIME, the Canadian Hydrogen Intensity Mapping Experiment radio telescope. Of the 10 repeating bursts detected so far, only the first 2 have been traced back to their sources. That first one, FRB 121102, exhibits very clustered bursts, sometimes remaining silent for hours and hours, and then suddenly exhibiting multiple bursts in a short amount of time. And one of the newly detected bursts has done the same thing. Another has repeated 3 times, but the remaining 6 have only repeated once. One clue as to what's generating these events is that individual bursts from repeaters appear to last a little longer and showed a downward drift in frequency with each burst getting successively lower, compared to flashes from one-off fast radio bursts. The authors were also able to measure the polarization of one of the new signals, FRB 180916, finding it to be really low. The polarization of the signals, that is how twisted the signal is, tells astronomers about the sort of magnetic environment the signal originated from. The more twisted the signal, the more extreme the magnetic environment. Some bursts, such as FRB 121102, suggest a highly magnetized environment, such as a black hole, a neutron star, or a magnetar. But FRB 180916's extremely low polarization suggests not all fast radio bursts originate in extreme environments. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
8 new fast radio bursts have been detected. These things are popping up from time to time, and as most things do in astronomy, they create more questions than answers. What do we know about these ones?
Not much, really. Quick potted history of fast radio bursts. First one discovered, I think it was 2006, although it was reported in 2007 by Duncan Lorimer of West Virginia University, if I remember rightly, and his team. They found this single blip in archival data from the Parkes Radio Telescope. They're actually looking for pulsars, these pulsating, rotating neutron stars. But they found just this blip of radio radiation, which was quite strong. And by analysing the details of it, something called the dispersion of the radio waves allowed them to realise that this was an object deep in space, probably 1 billion light years away or something like that. And then there was a succession of these things discovered by the Arecibo radio dish in Puerto Rico. So the objects are characterized by the fact that over a period of just a handful of milliseconds, there's this bright radio flash, which, given the distance of these things, which are kind of known to be what we call cosmological, which means a long way away, they are very, very energetic. You know, they push out 10,000 times what the sun emits in a year. They're huge amounts of energy and very brief. We still don't know what they are, but it was actually data from Arecibo, which I think in 2015 led to the discovery of the first repeating one of these, a radio burst, fast radio burst that actually repeats, not in a periodic way. It's quite a sporadic repetition, but the fact that it repeats means that you could look at the spot in the sky where it comes from and see, you could basically determine determine where this object is in the sky fairly accurately because it does it more than once, and then look at it with different sorts of telescopes, optical telescopes, that's visible light ones, infrared telescopes and things like that, and look at what's there. And it turns out that the repeater is in the sort of outskirts of a very ordinary dwarf galaxy at a distance of about 3 billion light years. Nothing really to tell you what is special about the environment in which this object exists. So, excuse me, in terms of repeaters, that was the situation at the beginning of this year. There was only one repeater. It rejoiced in the name of FRB 121102 to give it its proper title. Then in January, a second repeater was found, and that got people very excited. Meanwhile, many of the single-shot ones had been observed, and I think the total now is well over 100 of these single-shot fast radio bursts. But as I said, in January this year, the sum total of repeaters was 2, but then within the last couple of weeks, we've had a report from a telescope with the wonderful name of CHIME. CHIME is the Canadian Hydrogen Intensity Mapping Experiment, and it's a radio dish in British Columbia, or actually a succession of not so much dishes as troughs. They're telescopes that are fixed in space, low-frequency telescopes, and they have turned up 8 repeaters.
Wow.
So that's put a whole new dimension on this study of fast radio bursts. It looks as though something like 10% of all known fast radio bursts are actually objects that repeat.
That creates a mystery in itself.
You can imagine that, okay, if you've got these things that just pop off, so single-shot versions of the fast radio bursts, then you could account for that by some sort of cataclysmic event like the end of a star or something like that. But when they do it again and again and again, then that explanation doesn't hold up. And so theoretical work that's definitely going on in the background trying to understand these things is stuff that I'm not really very familiar with, but my colleagues in the fast radio burst trade, if I can put it that way, talk about flares on magnetars. Magnetars are very highly magnetized neutron stars, and apparently if they get flares on the surface, they can be very energetic. I'm not in a position to be able to judge whether that's a reasonable explanation. People have suggested colliding neutron stars as well, which we would perhaps be able to detect by gravitational waves, because we've seen evidence from gravitational waves of colliding neutron stars. So unfortunately, they don't sort of tally with fast radio bursts. But the mystery, I think, is still wide open, that we've got some of these things that repeat and some don't. The repeaters are in the minority, but they're not unique. That was the big news this year, and that's certainly what differentiates our present knowledge from what we would have been talking about this time last year when there was only one repeater.
I suppose we're also probably trapping ourselves in thinking, well, you know, this must be caused by similarities in events, but maybe not. Maybe there's all sorts of different ways fast radio bursts can be created that we might need to think a bit more outside the box.
Exactly. There's one person who's doing that, and that is Avi Loeb of the Harvard Center for Astrophysics. You and I have spoken about Avi before because he was very quick a couple of years ago to suggest that one possibility for such flashes in space might be people using radio lasers or something like that to propel light sails through the universe. It's an off-the-wall suggestion.
What, people other than us?
People other than us, that's right.
Oh, okay. That's interesting.
People of species and planets different from our own,
right,
whizzing light sails through the universe. I think that's a suggestion that most astronomers, they're slightly skeptical of, but nevertheless, it's a valid point because he says that the physical parameters are consistent with what you get, but that remains to be seen. I have to say that, Avi Loeb is very keen on the idea of solar sailing or light sail technology because he's part of the breakthrough Starshot venture, which is looking at the possibility of sending a light sail to Proxima Centauri. And he was also, I think, very quick to point out that when Oumuamua flew through the inner solar system, that's right, the very same, that might be an alien spacecraft with a solar sail rather than just an asteroid. So you get a theme here, and he's very provocative. That's the best way you can put it.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. If you'd like to help support Space Time and get access to the weekly double-episode commercial-free versions of the show, then come and join our Patreon family. It only costs a few dollars a month, it helps keep the show going, and we offer heaps of rewards. There's bonus audio content and an invitation to join our special Patreon-only Facebook group. We can come and chat, discuss the show, ask questions, whatever you want, with like-minded listeners and members of the Spacetime team. Get all the details at patreon.com/Spacetime with Stuart Gary. Now that's Patreon, spelled Patreon. Patreon.com/Spacetime with Stuart Gary. Details are also in the show notes, or just click on the orange button on our website. And thank you to all our Patreon listeners, because your generosity really does help to support our show. Astronomers have discovered a treasure trove of previously unknown ancient massive galaxies. The discovery defies current models of the universe and could shed new light on the mystery of dark matter. The 39 galaxies detected date back to the first 2 billion years in the universe's 13.8 billion year existence, and they raise questions about how they could have grown so massive so early in the history of the cosmos. One of the study's authors, Teo Wang from the University of Tokyo, says it's the first multiple discovery of its kind, and it opens new windows into the formation of supermassive black holes and the distribution of dark matter. More importantly, he says the finding contravenes current models for this period of cosmic evolution. Wang says these ancient galaxies were previously invisible to astronomy. But then again, how can something as big as a galaxy be invisible to begin with? Well, that's easy to answer. Because light from these galaxies is so faint and so far away, it's stretched out to very long wavelengths beyond the visible and near-infrared by the physical expansion of the universe over time. The further away an object is, the more space-time is stretched by the expansion of the universe. Astronomers refer to this stretching as redshift. It allows scientists to calculate how far away something is, which also tells you how long ago the light you're seeing was initially emitted from the thing which you're studying. As the universe expands, light passing through it becomes stretched, and so visible light becomes longer, eventually becoming infrared. That makes it undetectable by Hubble. So instead, the authors turn to ALMA, the Atacama Large Millimeter Submillimeter Array Radio Telescope in Chile. Wang says the team's initial suspicions about these ancient galaxies' existence came from the Spitzer Space Telescope's infrared data. But it was ALMA's even sharper eyes which peered through all the gas and dust of the early universe and was finally able to expose these ancient behemoths. Of course, the question now remains the same. How could galaxies get so big so quickly? And for that, we are yet to find an answer. I'm Stuart Gary. This is Space Time. Europe's second EDRS laser communications satellite has been successfully launched into orbit. Arianespace mission VA249 flew aboard an Ariane 5 rocket from the European Space Agency's Kourou spaceport in French Guiana.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage du Vulcain.
Right on time, Ariane 5 began her mission lifting off from the ground here in French Guiana with a lot of fire and with 2 new satellites rising into the bright blue sky, trailing exhaust flames of gold. The 2 boosters providing 90% of our thrust right now, propelling the launcher along her trajectory at an ever higher velocity. 775 tons at liftoff, hard to believe. But to get that sort of mass off the ground, you need a lot of push. And push we have. She's burning 5 tons of fuel every second. 2.5 tons are burning every second in each of the boosters. Plus, the core stage, the middle stage, burning another 300 kilos of fuel every second. Ariane 5 is now following the program in the onboard computer, which gives all the orders in Ariane on her way east across the Atlantic. Right now, the first flight phase, the single first stage engine and the 2 boosters are burning. The boosters burn just over 2 minutes.
La propulsion est nominale, la trajectoire est nominale, tous les paramètres bord sont normaux.
The DDO says everything is perfect on board, and he's announced the separation of the boosters. Boosters fall 500 kilometers from shore into a protected area. From our altitude, 104 kilometers, our speed, 2.27 kilometers per second. The speed we need to inject the satellites, roughly 8 or 9
Séparation de la
kilometers
quoi?
per second as we've separated the fairing. There are actually two halves. We can separate the fairing now because we're out of the denser layers of the atmosphere. Over 100 kilometers up, there's neither friction nor heating, which could disturb the passengers. We are coming up on cutoff of the lower stage, and there's the separation of the staging. There we are. These three commands given by the onboard computer in about 13 seconds. The lower stage will fall into the Atlantic off the Gulf of Guinea.
Séparation du satellite Intelsat 39.
The mission, of course, is not over yet. We still have to separate our final passenger, EDRS-C. Coming up on SILDA separation. The SILDA will be pushed away from the mothership, just like the satellites were. There's the scheduled separation of the SILDA.
Séparation du système de lancement double Ariane, le SILDA.
And the DDO has confirmed it, this time for the second passenger tonight.
Séparation du satellite EDRS-C.
The EDRS, or European Data Relay System, will be a constellation of geostationary satellites using laser technology to relay information and data between spacecraft, aircraft, and ground stations. It'll enable the observation of Earth in almost real time, allowing accelerated responses to emergency situations. Eventually, it'll also relay data from the International Space Station once the required equipment's installed aboard the ISS on the outside of Europe's Columbus laboratory module. The Ariane 5 launch vehicle used for this mission featured new elongated upper stage cryogenic tanks, allowing several hundred kilograms more propellant, giving 30 seconds additional burn time, and a 100 kilogram payload increase to geostationary orbit. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Cancer is now the leading cause of death in high-income countries, where it accounts for twice as many deaths as cardiovascular disease. A report in the Lancet Medical Journal looked at data from 21 high, middle and low-income countries. By following over 160,000 people for almost a decade, researchers found substantially higher rates of cardiovascular disease in low-income countries compared to its incidence in high-income countries. But they found that as cardiovascular disease rates fell, cancer could take over as the leading cause of death worldwide in just a few decades. A new study has concluded there is no consistent evidence to suggest that exposure to radio frequencies like those emitted from cell phones and base stations causes any health issues. The new findings, reported in the New Zealand Medical Journal, are the latest in a growing list of studies from around the world which have failed to establish a creditable link between mobile phone radiation and cancer. In fact, the authors found that studies which claim to show increased genetic damage or other biological effects are much more likely to have a lower quality of evidence compared to studies that showed no significant effects at all. While there are some studies which show that there is some health effects from exposure in a controlled environment such as a laboratory, they're not translating to what the general population is experiencing day to day. Probably another good reason why we shouldn't be using animals for testing. The European Space Agency's Copernicus Sentinel-2 satellite has imaged a giant 150 square kilometre raft of pumice drifting across the South Pacific Ocean bound for Australia's Great Barrier Reef. The pumice is believed to have come from an underwater volcano near Tonga which erupted on August the 7th. Pumice rock is full of holes and gas from the volcanic explosion which created it, and that makes the rocks light enough to float on the surface of the sea. The massive gathering of floating rocks has turned the ocean surface from its usual twinkling azure blue to a dull grey that almost looks like land. Scientists say the raft may cause some minor problems for navigation, but it could be bringing benefits for the Great Barrier Reef, as its millions of pieces of rock act like small vehicles, transporting small marine organisms such as algae, snails, barnacles and corals. Now, if the raft eventually does reach Australian shores, it's hoped that these hitchhiking organisms could help replenish the Great Barrier Reef, which has been damaged due to rising seawater temperatures caused by climate change. An almost complete skull of the oldest known human ancestor, Australopithecus anamensis, which has been uncovered in Ethiopia, contains features which are raising new questions about the evolution of some of Homo sapiens' earliest ancestors. The skull, which is thought to be from an adult male, has revealed for the first time what the face of this ancient relative really looked like. Previously, scientists mostly only had teeth and jaws to go on. These new details, reported in the journal Nature, have led scientists to now cast doubt on the widely accepted idea that this ancient ancestor evolved directly into another, namely Australopithecus afarensis, known as the famous Lucy fossil. Instead, they now believe these two ancient hominids are distinct from each other. In fact, they may even have overlapped by about 100 million years. Not so much a human tree as a human bush. After a patient, now given the codename RDS, suffered a stroke, he experienced a rare and unusual side effect in that when he saw something either red, blue or green, he could not actually name the object's colour, although he could tell when they were part of the same colour group. Previous research had suggested that colour categories only exist because of the language used to describe them. So researchers decided to test this hypothesis with patient RDS. The findings, published in the journal Cell Reports, determined that RDS could consistently name achromatic colours such as black, white and grey. But he simply could not recall the names of chromatic colours such as red, blue or green, suggesting the language system in human brains processes grayscale differently. Salespeople claiming they can improve a child's reading abilities simply by getting them to wear expensive glasses with coloured lenses have started promoting their products in Australian schools. They represent the American-based Erlen Institute, whose patented coloured filters are being sold as a treatment for what they like to call Erlen syndrome, scotopic sensitivity syndrome, or Mears-Erlen syndrome. As well as improving reading, they claim the coloured lenses also improve writing, concentration levels, and low motivation. They also reduce sensitivity to light, then again so do sunglasses. Now, while it all sounds great, the problem is the Royal Australian-New Zealand College of Ophthalmologists says there is no sound theoretical basis or scientific evidence that Erlen syndrome actually exists, or that the treatment with Erlen-coloured lenses really works. And that's a view strongly supported by leading American medical bodies. In a joint statement, the American Academy of Ophthalmology, the American Academy of Pediatrics, and the American Association of Pediatric Ophthalmology have all firmly repudiated the use of the coloured lenses, stating there was no scientific evidence supporting their use. Tim Mendham from Australian Skeptics says that hasn't stopped the company trying to sell their coloured lenses in schools.
Erlen syndrome was something that was, shall we say, discovered in about the 1980s, which is a theory that problems, especially with kids in reading, can be cured by wearing tinted glasses. The suggestion is,
yes.
Yeah. Suggestion is that certain wavelengths are sort of stopping people from effective reading, from learning, even some medical conditions, even sort of they throw in things like autism as well. This has been going now for a while. The particular person who was in charge of it was Helen Erlen, who launched an Erlen Institute, which patented coloured filters for supposedly treating the syndrome and selling them in glasses and things. And yeah, these are not cheap. They cost about $700 for the lenses. And then you've got to buy the frames and everything else to go with it. There is no evidence to show that these things work. These things run on anecdotal customer sort of testimonials and that sort of thing, but there's been no proper studies done to see if these things have any effect at all. And there is highly likely to be a placebo effect, or there could be that once people have these glasses, they feel more confident about reading, so the reading does improve. When it does, other times it might just be poor measurement. People are doing it themselves, so families are saying, oh, my kid is reading better now. You try and do that on a trial basis to see if these things work, but so far it hasn't. And someone's making a lot of money out of it.
And it's being promoted in Australian schools.
Yeah, there are various sort of people going around. You have to get these glasses or have to be assessed by an Erlen specialist. It's not just something your local ophthalmologist can do, and most ophthalmologists actually reject it. But yeah, some of these people from Erlen groups are going around to schools lecturing to teachers, especially, saying that your students who are not reading very well may need these sort of glasses, and teachers are keen to help out the kids, etc. And whether they're lecturing to groups of parents or lecturing to teachers, you are getting an infiltration in schools in various places. It's recently been in a number of places in Western Australia, but it's elsewhere as well. And really, there is no scientific evidence to suggest that it even works at all.
That's Tim Mendham from Australian Skeptics. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.